Hi, good afternoon. Thank you for watching my video. My name is SSC from singaporestudent.com. Today is the 6th of May 2012. The topic I would like to cover today is about mole calculation, and I already prepared a question about mole calculation, a simple one, and we are going to do this question, and to be able to explain to you faster, I already prepared the pattern to answer this question, a very simple one. Let's start by reading this question for you. Excess aluminum carbonate is reacted with 200 cm³ sulfuric acid solution with concentration of 0.3 mol per dm³. The first question they ask, question number 1, what is the volume of carbon dioxide gas produced at room temperature and pressure? Which is here, one of the product. The second question is, question number 2, what is the mass of aluminum carbonate that reacts with sulfuric acid? If you look at the question in details, the question gives two information about the amount of sulfuric acid, that is the volume, which is 200 cm³, and the concentration, which is 0.3 mol per dm³. And that information is enough for us to answer the question. Now, let me explain to you how the pattern is organized. Very simple. I already prepared some blue boxes here. So these blue boxes will represent the number of moles of substances in the reaction. In this case, the reaction is between aluminum carbonate and sulfuric acid. So we have that type of reaction whereby you have carbonate salt with acid. So you're going to get salt, carbon dioxide, and water. In this case, we are calculating the moles of three substances. Sulfuric acid, because sulfuric acid is the information about sulfuric acid is given in the question. And we are going to calculate two more substances, which is carbon dioxide, because the question asks for the amount of carbon dioxide, and also aluminum carbonate. So that's why we prepared three boxes. So usually when I explain, I standardize the mole of substances. I draw boxes in blue color, and for other units like the volume of gas or concentration of solution or volume of solution or the mass, usually I use these green boxes. Now we are going to put in that information into our pattern. This 200 cm³ and 0.3 mol per dm³ are the volume and concentration of sulfuric acid, so we put it here. The concentration is 0.3 mol per dm³, and the volume is 200 cm³, which is also 0.2 dm³. So we put it in a green box here because it's not in mole. So we can easily convert them into mole using formula number 4. Mole equals to volume times concentration, and we are allowed to use it because formula number 4 is applicable for aqueous solution, and sulfuric acid is an aqueous solution. So we just multiply. we multiply the volume and concentration, so we get 0.06 mole, and this mole belongs to sulfuric acid. So by knowing one of the number of moles of one of the substance, we can calculate the rest by using mole ratio. So all these blue boxes here will follow the mole ratio in the chemical equation. So the coefficient of sulfuric acid is 3. The coefficient of aluminum carbonate is 1. Remember that empty space means 1. And the coefficient of coefficient of carbon dioxide is 3 also. So we can easily calculate the mole of aluminum carbonate and carbon dioxide. The mole ratio is 1:3. We are following the mole ratio in the chemical equation. So 0.06 divided by 3, you're going to get 0.02 mole. And the mole of carbon dioxide is also 0.06 because the ratio is 3:3. Now, question number 1 is asking the volume of carbon dioxide. Very easy. And carbon dioxide is gas produced, gas at room temperature and pressure. And we can simply use formula number 3, which is volume of gas at room temperature and pressure is mole times 24 dm cube. So we just simply multiply 0.06 times 24. You are going to get 1.44 dm cube. So very simple. The volume of carbon dioxide produced is 1.44 dm cube. Question number 2. They are asking the mass of aluminum carbonate. We can simply calculate the mass by using formula number 1. Mass equals to moles times mR. We can easily calculate the mR, or relative molecular mass. Al is 27. Carbon is 12, of course. 12 plus 16 times 3, and the whole thing you multiply by 3. So 27 times 2 plus 3 times 12 plus 16 times 3. You get 126. So mass, we simply multiply 0.02 times 126. So we get 2.52 gram. Very simple. So the answer for question number 2 is 2.52 grams. Yeah. So that's how we answer the question about answer this question, right? And so if we revise what we learned today, basically if you encounter this type of mole calculation question, so you just prepare space. I standardize using blue boxes for moles of the substance that either they give information on or the one that they ask, and you prepare space also to calculate the amount of substance expressed in different units, either is concentration, volume, or mass. So Thank you for watching my video again. So hopefully this thing is useful for you. Thank you. Bye.